So I will be waiting for 2 minutes. Then I will be starting this session. So my voice is clear and my screen is visible to you.
Yes, ma'am.
So we will be starting this problem solving um, session. So hello everyone. My name is Himanshi Singh. Uh, I'm from Department of Mathematics, IIT Jodhpur, and I'm doing research here. I'm basically a PhD scholar, and I'm doing my research in a broad area of probability and statistics. So today we will be discussing all the concepts or the notions which has been introduced in week 6 lectures, and then we will be solving some of the problems based upon those concepts. So I hope you have you have watched all the lectures of week 6. So So in week 6, what has been taught? So first of all, this joint distribution has been taught. Now, up till now, we only have a single random variable. Now, in place of single random variable, if I have two random variables, for example, in place of single observation, if I'm interested to consider two different observations, one is noted by random variable x and other is noted by random variable y, then we will be having the concept of this random variable x comma y, which is also we can also say it as a random vector, because it contains two random variables, and also we can have same notions, all the things which we will be defining for these two random variables, those same notions followed for any random vector of length k. So we will be considering here for two random variables. So if x and y are the random variables, then their joint distribution will be given by this probability x less than equals to x comma y less than equals to y. Now there is a possibility that x is discrete, y is discrete. X can be continuous, y can be discrete, and both can be continuous, or one of them can be discrete and other is continuous. So here we are considering in general this cumulative distribution function for the random variable x comma y, and it has some properties that if y tends to infinity, fxy, then it will go towards fxx. And what is fxx we will be discussing further. And if x tends to y, this joint distribution will go towards fyy. And if y tends to minus infinity, or if x tends to minus infinity, this fxy goes to 0. And apart from this fxy is a non-decreasing in each x and y, so it will be non-decreasing, and also it will be continuous from the right side for both the arguments x and y. So this is basically the properties of the joint distribution, where fxx and fyy are the marginals, which we have already studied in week 6 lectures, and I will be discussing those marginal distributions as well in next slides. So now we are considering that x and y both are discrete random variable. Then the probability mass function of this random vector x comma y will be probability x is equals to xi, y is equals to yi. We will be denoting it by this pxy xi comma y. So this is basically yj here. This is yj and this is yj here. So we will be denoting the joint PMF by this pxy xi yj. and this probability for this random vector, this PMF should be greater than equals to 0. And if I sum it over all the values of x and all the values of y, then I should get the whole total probability equals to 1. So these are the three properties of the, so basically these two are the properties for the PMF, and this is the how we represent the PMF for random vector x comma y when x and y both are discrete. Now apart from this, so this there's a concept of marginal distribution. So if x and y are the random vector, and if I want to find out the PMF of the random variable x, then how will I be finding that? So pxx will be summation of the joint PMF, and we are summing it over all the values of y. Then we will get the PMF for the x, which is basically called the marginal distribution of x. And similarly, if I sum the PMF for the joint random variable xy, if I sum it over all the values of xi, then all the values of x, then I will be getting the marginal distribution of y. So these are the marginal distributions which is defined for a random variable x and y. So here we will notice that we are summing it all over all the values of x, then we are getting the marginal distribution of y. So we should keep that thing in mind. Then now apart from this marginal distribution, we have this conditional distribution. So basically the conditional PMF of x given y is equals to yj. So if I have this information that the random variable y is yj, then what will be the PMF of x given y equals to yj? So this will be nothing but the joint PMF divided by the marginal PMF of y. So when we have discussed about the event, so basically what we have given that probability A given B is equals to probability of A comma B divided by probability of B. So we can get the intuition for the random variables also from there. So here the numerator is the joint density between x and y, and the denominator is the marginal for y. And similarly, if I consider that conditional PMF of y given x, then it will be the joint divided by the thing which is in the which is given. So that is marginal of px, the marginal of x, that is px xi. And marginals we can find out by doing the summation which I have discussed in the previous slide. So these are the conditional PMFs. Now similar kind of thing we can do for the continuous distribution also. Like if I have both the random variables to be continuous, then I can define this joint PDF. So we will just represent that joint PDF by f x comma y. So this will be the joint PDF, and this joint PDF, because it is a probability kind of thing, so it will be greater than equals to 0 for all x comma y in R square. And the since this is a continuous random variable, both are continuous, so the double integral ranging over minus infinity to infinity, it will be this integral should be equal to 1. And also if I have a subset of R square, now if I have this the whole R square, now if I consider this subset of R square, this thing, this to be B, now if I consider, and if I want to find out that what will be the probability here for this region, then what I will do, I will integrate the joint density over that region B, that is integration over that region B. So it will be the probability that x comma y belongs to this region. So the joint random variable belong to this region will be the probability of that event should be equal to the double integral of the joint density, and we are doing the integral over the region B here. So this is basically the joint PDF. So here we are considering the both the random variable to be continuous. Now apart from this also, we can also have the concept of marginal and conditional distributions. So the marginal for here, the marginal PDF of x will be, we are integrating the joint over the values of y, and we are getting the marginal of x. And similarly, if I want to get marginal for y, then I will be integrating the joint with respect to x, and I will be getting it the marginal for y. So this is the marginal distributions. And if I want to calculate the conditional PMF, then the density of x given y. So this x given y is also a random variable. So the density of x given y will be nothing but the joint density of x comma y divided by the marginal of y. And the conditional PMF for y given x, if I want to find out, then it will be the joint density divided by the conditional for x. So these are the conditional distribution, and here of course we need that this marginal f by y and marginal fxx should be non-zero, otherwise this will not be defined. Now apart from this, we have this this is the conditional PMF only. Now apart from this, we have this concept of independence. So when two random variables are said to be independent, so if this joint PMF, if the random variables are discrete, and if the joint density, if the random variables are continuous, if we can write it as a product of the PMF of the individual random variables or product of the individual densities of the random variable, then we will say that the random variable, both the random variables are independent. So if I want to check that whether two random variables are independent or not, what I will find out? First of all, I will be having the joint density. Then from that joint density, I will be finding out the marginals for x and marginal for y. Then I will product those marginals and see whether the joint density is equals to the product of the marginal or not. And if it is equal to, then the random variables are said to be independent. Otherwise, they will not be independent. Now, so this is the concept of basically independent random variable. Now, apart from this, these product movements are there. So, in case of the single random variable, what we have considered, that expectation of x to the power r we have considered, and we say that this is a non-central movement for x. Now, if we have two random variables, then we will consider the r sth non-central product movement. So that will be equal to the expected value of x to the power r, y to the power s. So this will be the rsth non-central product movement. And if I want to consider the central product movement, so it will be the expected value of x minus mu x to the power r, y minus mu y to the power r, and we will consider this expected value, and this will be the r sth central product movement. Now, in when we consider the single random variable in there, we have find out the concept of the variance of a random variable, that expected value of x square minus expected value of x whole square. We called it as the variance of the random variable x. Now here, due to these product movements, there is a concept of the covariance of random variable x comma covariance between random variable x comma y. So if I consider this mu 1 1, so this is the 1 1 central movement. So that is expected value of x minus mu x, y minus mu y, which is equals to expected value. If I product them, then I'll be getting expected value of xy minus mu x into mu y, which is nothing but expected value of xy minus expected value of x, expected value of y, which is which we will be denoting by sigma xy, and we call it as a covariance between the two random variable x and y. So here this concept of covariance is there, so that which is nothing but expected value of xy minus expected value of x, expected value of y. Now, apart from this covariance, there is a concept called coefficient of correlation, which we will be defining using the notion of covariance. So, this coefficient of correlation is the ratio of covariance between x and y divided by the standard deviation of x into standard deviation of y. So this is basically sigma xy divided by sigma x into sigma y. So now this quantity uh, will be between minus 1 and 1. And what is this coefficient of correlation basically? So it measures the linear relationship between the random variable x and y. So if I have a two random variable x and y, and if there is some linear relationship between x and y, then it will be measuring that degree of linear relationship. So basically, if that this quantity rho x y is 1, means they are perfectly linearly related. Okay. Now, if this rho xy is minus 1, then we'll say that it is perfectly negatively linearly related. Now, if rho xy is 0, then we'll say that x and y are uncorrelated, means x and y have no linear relationship. There can be a non-linear relationship, but x and y do not have linear relationship if the coefficient of correlation is 0. Now, if this coefficient of correlation is greater than, sorry, it is 0, and this is 0 here. So, if this coefficient of correlation is greater than 0, then we will say x and y are positively linearly correlated. And if it is less than 0, then we say that they are negatively linearly related. So this is basically the interpretation, and it will measure the linear relationship between the random variable x and y. However, it do not tell anything about the non-linear relationship. Now if I have x random variable which is equals to y square, then x and y are non-linearly related, so there is no linear relationship between them. So in that case, it will not tell anything about the relationship. But if x is equals to something like ay plus b, then it will measure the linear relationship based upon the constant a and b, whether they are positive or negative. So in this kind of situation, it do not say anything, but it generally measures the linear relationship between x and y. So this is basically the concept for the coefficient of correlation. Now, apart from this, there is a theorem that if I have two random variables, two independent random variables, and if I consider function of x and function of y, and if I consider the expected value of the product of g of x and h of y, then I can just distribute the expectation over the over both the functions. That is expected value of gx into expected value of hy. So if x and y are independent random variable, in general we cannot do this. But if x and y are independent, then we can just uh, we'll just give the expectation to gx and hy, and we are done. Now, so this is basically the general case. G and h can be any functions, measurable functions, of course. Now, in place of g and h, if I have x to the power r as a function of x and y to the power s as a function of y, then if n x and y are independent random variable, then this quantity is equals to expected value of xr into expected value of ys. Similarly, expected value of x minus mu x to the power r, y minus mu y to the power s will be equal to expected value of x minus mu x to the power r, expected value of y minus mu y to the power s. Yes, so we are basically considering the movements. So if I have r and s to be 1, then this will be nothing but expected value of xy. So that will be equal to expected value of x into expected value of y, which will imply that if x and y are independent random variable, then covariance will be 0 for that. So next theorem is about that only. If x and y are independent random variable, now if x and y are independent random variable, what it will imply that expected value of xy, because of the previous theorem, is equals to expected value of x into expected value of y. So which will imply that the covariance between x comma y, whose numerator term is the difference of these two, so which will be 0. Now if covariance is 0, imply that the correlation is 0. So basically, if I have two independent random variables, then their their correlation coefficient will be 0, means they are uncorrelated. But if I consider the converse part, that if they are uncorrelated, then that does not imply that x and y are independent random variables. So the correlation is 0. This will imply that x and y are not linearly related. So there will be no linear relationship between x and y, but they can be dependent. The relationship may be of some other kind, but they will not be linearly related. But in general, they may be dependent on each other. So we cannot say that x and y are independent. So this is basically the theorem for that. Now we will be considering the joint moment generating function of x and y. So if I two random variable mxy st will be the moment generating function, which is defined as expected value of e to the power sx plus ty. So for single random variable, what we had expected value of sx. Okay, now for two random variable, it will be the expected value of e to the power sx plus ty, provided that the provided that this expectation exists in the neighborhood of 0 comma 0 basically. Okay, so this is a joint mgf of x and y. Now, there is a theorem that if x and y are independent random variables, then this joint MGF can be written as product of the individual MGFs. So, in case of the independent random variable, we have this facility that we can write the joint movement generating function as a product of the individual movement generating function of x and y. Otherwise, we cannot we cannot write. And also it is an if and only if condition. So if I can write the moment generating function, joint moment generating function, as a product of the individual moment generating function, then we can say that x and y are independent. So this is basically the if and only if condition for the independency. So apart from the covariance thing, um, so apart from the so to prove the independency, we have this condition that the joint PDF should be equal to the product of the marginals. Apart from this, we can also use this condition in order to prove the independency of two random variables. So again, we have another theorem that if x and y are independent random variables, then the moment generating function of the sum of these two random variable is nothing but the product of the individual moment generating function of x and y. Now this is just this is one way true. This is not the two way true. So it is not a if and only if condition. So if I have x and y independent random variable, then it is easy to find the moment generating function for the sum of the random variable, which is nothing but the product of the moment generating function of both the random variable x and y. So this is basically in order to find the moment generating function of x plus y. And if we know the moment generating function of x and y, then also talk about the density of x and y, x plus y. Now, apart from this, we have bivariate normal distribution. So we have already studied this normal distribution where the density was of the exponential form. So here, if I have two random variables, then what will be the bivariate normal distribution? So it will be the so obviously we are considering x and y to be continuously jointly distributed random variable. Then they will be said to have a bivariate normal distribution if their density is of this form. So basically 1 upon 2 pi sigma 1 sigma 2 under root 1 minus rho square and exponential of this whole quantity. So this here this mu 1 mu 2, so these are real numbers. Sigma 1 sigma 2 are positive and rho is lying between minus 1 and 1. And so this will be the density of bivariate normal distribution. Now if I consider the marginal density of x and y for this joint density, then this marginal density, so I will be summing those results in this theorem. Now, if x and y are bivariate normal distribution with mu1, mu2, sigma 1 square, sigma 2 square, and rho parameters, then the conditional and marginal distribution will also be univariate normal. And what are their parameters? So x will be normal with mean mu1, sigma 1 square to be the variance. Y will be normal with mu1, mu2 mean and sigma 2 square as variance. X given y will be normal with mu1 plus rho sigma 1 y minus mu2 by sigma 2 as their mean and sigma 1 square 1 minus rho square as its variance. And y given x again will be a normal distribution with mean as mu2 plus rho sigma 2 x minus mu1 by sigma 1 and variance as sigma 2 square 1 minus rho square. So we can, if I have a bivariate normal distribution, then their marginals and the conditional distribution will be normal univariate normal distribution with the given mean and variances. Conversely, if I consider that the marginal and conditional distribution are univariate normal, then their joint distribution will be bivariate normal distribution. So if I have x to be a normal distribution, y to be a normal distribution, and x given y is again a normal and y given x is again a normal distribution, then the joint distribution, this x comma y, will be a bivariate normal distribution. So converse is also true for this condition. So this is true for this bivariate normal distribution. Now this bivariate normal distribution is very important as it has certain qualities. So we will be discussing that in next theorem. So I will be discussing that first. So if x and y are bivariate normal distribution with mean mu1, mu2 and sigma 1 square, sigma 2 square rho, then x and y are independent if and only if the rho is zero, means the correlation is zero, means the covariance is zero. So basically here, if x and y are independent, so the independent condition is holding if and only if with the correlation. So if they are uncorrelated, then they will be independent, and if they are independent, then they will be uncorrelated. So basically here the if and only if condition is holding. This is for the bivariate normal distribution. This is not true in general. So this is not true in general. In general, for every distribution, this is not true. So this part is true for all, but this part is not true. The converse part is not true, but the converse part is also true for the bivariate normal distribution. Apart from this, if I have the joint distribution x comma y, the joint distribution of x comma y to be bivariate normal, if and only if I consider the linear combination of x and y, then it will also be a bivariate normal distribution. Sorry, it will be not a bivariate, it will be a normal distribution with mean a mu 1 plus b mu 2 and the variance as a square sigma 1 square b square sigma 2 square plus 2ab rho sigma 1 sigma 2. So basically if I consider a bivariate normal distribution, then if I consider the linear combination of these random variables, then it will be normal with this mean and variance. Here it is an if and only if condition. So if I have this to be a this normal distribution, then the joint distribution of x and y will be a bivariate normal distribution. And here we are considering that a and b cannot be both zero. Both cannot be zero simultaneously, because if both will be zero, then this variance will be zero, which is not which will not be giving a good like interpretation of a random variable. So yeah, apart from this we have this how can we find out this expectation of this function of random vector x comma y. Now if I consider that x comma y has a joint density fxy, then if I want to find out the expected value of gxy, then directly I have this formula that I will double integrate it over gxy, and like this will be multiplied by the joint density, and I will integrate it over dx and dy. Apart from this, if I have a conditional, what will be the form when I will consider the conditional concept in this thing. So how can we can I calculate this expectation using the conditional expectation? So in place of the integral, which is so in place of the joint density, what we have done, we have just divided by the joint density and whole term by the marginal of y, and we have multiplied just by marginal of y. And because y is constant with respect to x, so we have taken it outside this x thing. And integral of so integral of this will be so integral of this will be so fxy, the joint density divided by the marginal density. So it will be the conditional density fx given y. So this will be the same. The other terms will be same. Now apart from this, if I consider this term only, then this term will be nothing but the expectation of gxy with respect to this conditional random variable x given y. So this will be expected value of x given gxy with respect to x given y. Now again, I am considering the integration of this over f by y dy. Now this will be the expected value of this whole term with respect to y. So it will be expected value of y of this whole quantity, this one. So if I know the conditional random variable x given y, then I can find out directly the expected value of this thing. And if I know the density of y, then I can just find out the expected value of the resultant quantity. Then I will be able to find the expected value of gxy. There are many methods by which we can find out this expected value of gxy, but all the methods will be dependent upon whether the distribution of x and y are known, and it can be easily evaluated or not. So if the conditional distribution is easily if we can evaluate the conditional distribution easily, then we will be using this concept. Otherwise, we will directly calculate the joint this expected value of this function of random variable, random vector. In fact, I should say. So it will always be dependent upon the information which we have. We will apply that method according to that only. So yeah, these are these all the concepts which we have already studied in week 6 lectures. If any one of you have any doubt in these, you can, you may ask. Okay, so if there are no doubts, then I will be proceeding with the questions. So, so we have question one, that two balls are drawn without replacement from an urn containing four white, two black, and four red balls. So let xi be a random variable. It is taking value 1 or 0. So since it is, we can say, so it is taking values 1 or 0. Now, how the probability is given? So it is the random variable xi will be 1 if the ith draw is white, and it will be xi will be 0 if the ith draw is not white. So the probability is giving like that. And what we need to find, we need to find the conditional probability. So basically we need to find the conditional probability. So for that we first have the joint, uh, the joint distribution, and we should have the marginal distribution. So we know that probability x given y will be nothing but probability of x comma y divided by probability of y. Now for that we should have these two these two things, the joint and the marginal. Now for that we need to find out the joint distribution or the joint PMF of this random variable. So I will be making table for that. So first of all, we have this random variable x1 here and x2 here. Now x2 can take value 0 and it can take value 1, and x1 can take value 0 and it can take value 1. Okay, now what is this? Probability x1 is equals to 0 and x2 is equals to 0. So what is basically this event? So this event is, it is saying let xi, so let us consider I to be 1. So let x1 be a random variable which take value 1 when the first draw is white. So let me just first define these random variables, what they are. So x1 is basically, x1 is 0 if first draw is not white. x1 is equals to 1 if it is white. So we are talking about the first draw here. Okay. Now x2 means we are talking about the second draw. It is 0 if second draw is not white. And x2 is equals to 1 if second draw is white. Okay, so x1 is equals to 0 and x2 is equals to 0 means the first draw is not white and the second draw is not white. So what is the probability that the first and second both the draws are not white? So there are 6 not white balls. So 4 to 6 are the balls which are not white. So the probability that first is not white will be 6 by 10 and second is not white. Again we are taking, so one of the ball we have already taken and it is without replacement, so other will be 5 by 9. So this will be 6 by 10 into 5 by 9. For first and second both the draws are not white. Now if the first draw is not white means 6 by 10, and the second draw, x2 is 1, second draw is white. So second draw we are taking from this 4. So this is 4 by 9 because it is without replacement. Now first draw is white here. So first draw is white means it is 4 by 10, and second draw is not white, so that is 6 by 9. and both the draws are white, means we are taking it from the white one. So 4 by 10 into 3 by 9. So is it okay? Any doubt in this? So it will be how much? So it will be 1 by 2 times, 3 times, and 2 times. So it will be 1 by 3. So it will be 1 by 3, or I can write it in a different way. So it will be 5 by 15. And similarly, if I calculate this, it will be 4 by 15. And it will be again 4 by 15. And it will be 2 by 15. Now this is what? So here we will calculate that probability x1 is equals to x1. So here if I add these probability, I will get probability x1 is equals to 0. So it will be 9 by 15. And here if I add this one, I will get probability x1 is equals to 1. So it will be 6 by 15. Okay. Now this is probability x2 is equals to x2. Now probability x2 is 0, is the sum of this thing. So this will be 9 by 15. And probability x2 is equals to 1 will be sum of this. So it will be 6 by 15. And if I add this up, so it will be 1. So what I'm getting here now, that so what I need to calculate first, probability of x2 is equals to 1. So I need to calculate probability x2 is equals to 1 given probability x1 is equals to 0. X1 is equals to 0. So what I need to find out, the probability x2 is equals to 1 comma x1 is equals to 0 divided by probability x1 is equals to 0. Now from the table I have x2 1 and x1 0. So x2 is 1, x1 is 0, so it is 4 by 15. So it is 4 by 15. And what is probability x1 is equals to 0? So this is probability x1 is equals to 0 is this 9 by 15. So this is 9 by 15. So this is nothing but 4 by 9, that is 2 by 3. So this is basically the asked question, that is probability that x2 is 2 given x1 is 0. So any doubt in this? In calculating this joint densities and the marginals and calculating finally the conditional one. Any doubt in this? Or is it clear? It is clear? At least response. Okay. Okay, if it is clear, then I will be moving forward. So here now we have this continuous random variable where the joint density is given as fxy is equals to 6 into 1 minus x minus y, where x is ranging from x is greater than equals to 0, y, so x and y both are positive, and x plus y is less than equals to 1, and 0 it is otherwise. So first of all, we will just see that where the probability is positive basically. So where the density is positive in fact. So first of all, let us draw this region. So this is x is greater than equals to 0, y greater than equals to 0 means we are considering the first quadrant only. X plus y is less than equals to 1 will be this line. So this is here 1 comma 0, here 0 comma 1. So we are basically considering this region, and at this region our density is positive. Otherwise it is always everywhere 0. We need to calculate the expected value of x given y. Okay, y is equals to y something, or we can say. Now, in order to calculate this, we should have this conditional density for this. Okay, to calculate, we need what we need conditional density fx given y. which is equals to nothing but fx comma y divided by f y y. Now, in order to calculate the conditional density, we need the marginal density of y. So, we will be first calculating the marginal density of y. So, marginal density of y. So, that is f y y, which is nothing but integration of the joint density with respect to the random variable x. Now where the x is ranging basically, so what we have, x is greater than equals to 0 and x plus y less than is equals to 1. So basically x is less than is equals to 1 minus y. Okay. Now, since x is less than is equals to 1 minus y and x is greater than equals to 0. Okay. So, the integration will be from 0 to 1 minus y. Okay. Now, the density we are defining for y, then where the y is varying. So, basically y is greater than equals to 0, but y is less than is equals to 1 minus x. Okay, so let me write this. So where the y is varying, so y is greater than equals to 0 and y is less than equals to 1 minus x, where x is greater than equals to 0. Now y is greater than 0 means y is positive and x is greater than equals to 0 means y will always be less than is equals to 1. So y is basically ranging between 0 and 1. So what we are defining the condition, this marginal to be 0 to 1 minus y, and what is the joint density? Joint is 6 into 1 minus x minus y dx, and where y is between 0 and 1. Okay. So this will be the condition to this marginal density. So let's calculate this what it is. So 6 will come outside. It will be integrating. We are integrating with respect to x. So it will be x square by 2 minus x y and 0 to 1 minus y. So it will be equals to 6 into upper limit we are putting. So it will be, so lower limit will be 0 because we are having all the terms to be 0. Upper limit for 1 minus y, 1 minus y minus 1 minus y whole square by 2. Okay. Now other one is minus xy. So minus xy means y is there and in place of x we are putting 1 minus y. So let's take 2 in the numerator and we'll cut it by 6, so it will be 3. So it is 2 minus 2y minus 1 minus y whole square minus 2y plus 2y square. Now it is equals to 3 into 2 minus 2y minus 1 square y square plus 2y minus 2y plus 2y square. So it will get cancelled by this, and 2 minus 1 is 1 here, and this minus 2y is here, and this 2y square minus y square will be y square here. So it is nothing but it is 3 into 1 minus y whole square. So this is basically the marginal of y, where y is ranging over 0 and 1. Okay. Now if I want to find the conditional, so it will be f x given y, x given y will be the joint density divided by the. So it is nothing but what is the joint density we have? The joint density is 6 into 1 minus x minus y. 6 into 1 minus x minus y. And what the conditional we have found out to be 3 into 1 minus y whole square. So 3 into 1 minus y whole square. So it is 2 into 1 minus x minus y divided by 1 minus y whole square. This is basically the conditional. So we need to find the expected value of x given y is equals to 3. So expected value, so first of all we will find out that So f x given y is equals to 3 will be twice of 1 minus minus 2 minus x divided by 4, it will cut. So what is expected value of x given y is equals to 3? So it will be nothing but integral over x f x given y and dx, which is nothing but 3 here, and we are putting the limit. So limit is ranging, so we will not be finding out this way. So actually, first of all, in place of the expectation, we will find out first of all the expectation of this, because we are just putting the limit here. So it is expectation of, in general we will find out x given y and expectation of x given y will find out. So it will be in the form of y, and we will put the value of y there. So integrating, we are integrating it with respect to x, and where the x is ranging over. So x is ranging, it is greater than equals to 0 and it is less than equals to 1 minus y. So it will be from 0 to 1 minus y. Okay, so it will be expected value of x given y is equals to, so the fx given y is twice of 1 minus x minus y divided by 1 minus y whole square. Minute. So you just calculate this, the expected value, and just let me know what it is coming. So if I want to put the value here, so it is from 0 to 1 minus y, and we have x into, what is the conditional one? So it is 2 into 1 minus x minus y divided by 1 minus y whole square. And we are integrating it with respect to x. Okay, so it will be equal to, we can take the y term outside, 1 minus y whole square, and we will integrate this term. So it will be 2x first, so first one, so it will be 2x square by 2 minus, it will be 2x square. So okay, I can take 2 also outside. Okay. So I can take 2 outside, 2 upon 1 minus y square. So it would be x square by 2 minus, it will be x square. So it will be x to the power 3 by 3 minus, it will be y into x square by 2. And the limits are 0 to 1 minus y. So the lower limit will be 0, of course. So we are just considering the upper limit. So it is 1 minus y whole square. And we'll put it here, 1 minus y whole square by 2 minus 1 minus y whole cube by 3 minus y into 1 minus y whole square by 2. So here this 1 minus y square, this it will be cancelled, this power will be gone and this will be gone. So it will be twice of 1 by 2 minus, so it is 1 minus, you can directly write. If I combine the first and last term, so it will be 1 minus y by 2 minus, this is 1 minus y by 3. So it will be nothing but, if I take the LCM 6 and cut it by 2, so it will be 3 here, and this will be 1 minus y here. So it will be 1 minus y by 3. And if I want to calculate for y to be what it is, it has been asked to be y equal to 1 by 3. So expected value, let me add this. So it will be, so expected value of y given, sorry, expected value of x given y is equals to 3 will be, so here we will just put the value to be 3. So it will be 1 minus 3 upon 3. So that will be minus 213. So any one of you have solved this? Oh, sorry, not at 3.
Yes, ma'am.
Yeah, we have solved. We should solve it for 1 by 3 in the question as it is asked. So it will be 1 by 3 here. So 3 minus 1, that is 2 by 9. So you are getting the same answer?
Yes, ma'am.
Okay. Okay, then we will be moving forward then towards the next question. So suppose a two-dimensional random variable we have, which can take values I, j, where I is running from 0 to 2 and j also 0 to 2. So because we have two-dimensional random variable and further with a probability c into 2i plus 3j, where c is a constant, and we need to find out the PMF expected value and the variances of x and y. Now, in order to do that, first of all, we'll just construct the table for the joint distribution. So let me consider this one, and here we have this x and here we have y. So y can be 0, y can be 1, y can be 2, and we will have here the probability x is equals to x. And here x can be 0, x can be 1, x can be 2, and here we will have probability y is equals to y. Okay. Now x is 0, y is 0. So here the probability, okay, I can write it here. Probability x is equals to I, y is equals to j is nothing but c into 2i plus 3j. So when I and j are both 0, so it will be 0, of course, no doubt in that. Now if x is 0, y is 1, so it will be 3c. If x is 0, y is 2, it will be 6c. If x is 1, y is 0, so it will be 2c. X is 1, y is 1, it will be 5c. X is 1 and y is 2, it will be x is 1 and y is 2. Y is 2, we have 6, so it will be 8c. So x is 2, y is 0. X is 2 here, so it will be 4c. X is 2, y is 1, so it will be 3 plus 4, 7c. X is 2, y is 2. Both are 2, so it will be 4, it will be 6, it will be 10c. So all of these are correct. I hope it is correct. So these are the, so this is the basically the table for the joint density or joint PMF we can say. Now, so we have already find out the joint PMF using this table. Now, what will be the marginals? Because in order to find out the expected value of x, we need the marginal distribution for x. Now, probability of x is equals to 0 will be the sum of this one. So it will be 9c. Now, probability x is equals to 1 will be sum of this one. So it will be 15c. And the probability x is, sorry, probability x is equals to 2. Yeah, it will be sum of this thing. So it will be 21c. Okay, now if I calculate the probability y is equals to 0, it will be 6c. It will be 15c again. So, and this will be 24c. Okay, so we know that here we get the total probability, which should be 1. So here if I add this, so it will be 45c. So in order for this the joint density should be to be a probability density, the 45c should be equal to 1. So what it implies? So which implies that 45c is equals to 1. So which implies that C is nothing but 1 by 45. Because we need to find out the expectation and all those things, so we should know about the C. Now further we need to calculate the marginal. So probability X is equals to 0 is what? So probability X is equals to 0 is 9C, that is 9 by 45, which is 1 by 5. Probability X is equals to 1. Probability X is equals to 1 is 15C. 15 by 45, that is 1 by 3. Probability X is equals to 2 is 21C, is 21 by 45. Okay. Now probability Y is equals to 0 is 6C. So 6 by 45. Probability, here I have it right, probability Y is equals to 1. So let me calculate first, because it will be easy for me. Let me calculate first the expectation of X, then I'll calculate the probabilities for Y. So here we know that if I want to find out the value of expected value of X, so it will be summation over x into probability X is equals to X. So basically we are running over X. So X is 0, 1, 2. So for 0 it will be 0 only. So it will be, so expected value of X will be, so 0 for 0 it will be 0 plus for 1 into probability of X is equals to 1, that is 15 by 45, plus for 2 it will be 2 into probability X is equals to 2, that is 21 by 45. So it will be 15 plus 42 by 45, that is 57 by 45. Okay, so this will be the expected value of X. Now I will write the uh, PMF for Y. So probability Y is equals to 0, probability Y is equals to 1, and probability Y is equals to 2. So probability Y is equals to 0 will be, it will be 6C, 15C and 24C. So it is 6C, 15C, 24C. That is, it is 6 by 45, by 45. Now if I want to calculate the expected value of Y, so it will be 0 for the first one. For second one it will be 15 by 45 plus 2 into 24 by 45. So it will be 15 plus it will be 48 by 45. It will be 53 by 45. So is it coming same? You have calculated it? Oh, sorry, 63 will be there. So anyone of
63
you?
by 45.
What?
63 by 45,
Yeah,
ma'am.
yeah, it is 63. Yeah. So we have calculated the expected value of X, expected value of Y. Now we need to calculate the variance of X. So for variance of X, we need expected value of X square minus expected value of X whole square. So what is expected value of X square? So it is 0 probability X is equals to 0 plus 1 probability X is equals to 1. Now probability X is equals to 1 is 15 by 45. Okay, 15 by 45 into 1 plus 2, for 2 it will be 4 into probability X is equals to 2. So which is 21 by 45. So it is 21 by 45. So just calculate it. What is it coming? It will be 15. It will be 4, 84. 84 plus 15, that is 99 by 45.
Yes, ma'am.
Okay. Now expected value of y square. Sorry, now we'll calculate the variance first. So variance of x will be 99 by 45 minus we'll expected value of x whole square. And what is expected value of x? So that is 57 by 45. So it will be 57 by 45 whole square. Just calculate it. So first if I want to simplify it, then it will be 33 by 15 minus it will be 19 by 15 whole square. So I take the LCM, 33 into 15 it will be minus 19 whole square. Okay, just in the fractional form, just let me know what is it coming.
One 34 by 225.
134 by 225. Okay.
225.
Yeah, it is correct. Now expected value of y square we need to find out in order to find the variance of y. So it will be 0 into probability y is equals to 0. It will be 0 only. So 1 into probability y is equals to 1. So what is probability y is equals to 1 is 15 by 45. It will be 15 by 45 plus 2 square, that is 4 into 24 by 45. Probability y is equals to 2, that is 24 by 45. Yeah. Now we will find out this expected value. So it will be 15 plus 4 4 16, 96 by 45, which is 111 by 45. So variance of y will be 111 by 45 minus expected value of y whole square. So expected value of y is 63 by 45. So it is 63 by 45 whole square. So we can like
38 by 75.
38 by 75.
Yes, ma'am.
Okay. Okay. So it will be variance of y 38 by 75. So I'm not sure about it. Um, so I hope that you have like calculated it correctly. Okay. So all the things we have found out. We have found out the variance of x, variance of y. So yeah, we are done with this. So basically, what we have done, we have just first of all created the probability mass function for the joint random variable. Then we have find out the expected value of x, expected value of y, and their variances. Okay. Now we'll move forward towards the next question. So it is saying that find the marginal distribution of the random variable x1, x2 given as in question 1, and also find the covariance between these random variable and the correlation coefficient. So basically we need to find out the marginal distribution for the question number 1. So for question number 1 we already have this table. So we have probability x1 is equals to 0 to be 9 by 15. So we already have this marginal distribution. No, we have not found out the marginal. So we'll find out the marginal one. So probability x1 is equals to 0 will be 9 by 15. So probability x1 is equals to 0 is 9 by 15, and probability x1 is equals to 1 was 6 by 15. Okay. Now we can see one thing here, that if I consider the random variable x2, then also we have same probabilities. Probability of x2 is equals to 0 to be 9 by 15, and x2 is equals to 1 to be 6 by 15. Same thing we have. x2 is equals to 0 is 9 by 15. So basically x2 and x1 are taking same values. Marginal distribution for x1 and x2 are same. Okay. So which implies that expected value of x1 is equals to expected value of x2 because they are having the same same PMFs. Okay, so their expected value will be same, and the variance of x1 will be equal to variance of x2. Okay. Now, first of all, we need to find out the covariance. Okay. So, covariance between x1 and x2 will be expected value of x1, x2 minus expected value of x1 into expected value of x2. So, let's first find out the expected value of x1. So, expected value of x1 will be, first term will be 0 into 9 by 15. So, it will be 0 plus 1 into 6 by 15. So it will be 6 by 15, and which will also be the expected value of x2 because they are having the same PMF. Now we'll calculate the expected value of x1 into x2. So for that, first of all, calculate the PMF for x1 comma so x1 into x2. So basically x1 can take values from 0 comma 1 and x2 can take value 0 comma 1. So their product x1 into x2 will take value 0 or 1. So because if I find the product of this thing, it can be 0 or it can be 1. So probability x1 into x2 is equals to 0 will be what? That probability x1 is 0, x2 is 0. It can be this scenario, or it can be probability x1 is 0 and x2 is 1. It can be this scenario, or probability x1 is 1 and x2 is 0. Means either of them is 0. Then this will be the probability x1, x2 is equals to 0. So that is what. So we'll add up. So probability x1 is equals to 0, x2 is 0. So these probability we need to calculate from the table which we have made initially. So it will be x1 0, x2 0 is 5 by 15. So it is 5 by 15 plus x1 is 0, x2 is 1. So that is 0, x1 is 1, that is 4 by 15, and otherwise also it is 4 by 15. So it is 4 by 15 plus it is 4 by 15. So that is 5, 4, 9, 13 by 15. Okay. Now we need to calculate that probability x1, x2 is equals to 1. So that will be only one case, that probability x1 is 1 and x2 is 1. Both are 1. Okay. So which will be equals to, so what was the joint for that? We have x1 is 1, x2 is 1, that is 2 by 15. So we have this to be equal to 2 by 15. Okay. Now you can see also that x1, x2 is a random variable which is taking value 0 and 1, and probabilities are these, and if I add them, then it will be 1. So the probability, total probability will be 1. Now what we need to calculate? So we need to calculate the expected value of x1, x2. So expected value of x1 into x2 will be, so x1, x2 will be 0 if I take this one, so it will be 0 into probability x1, x2 is equals to 0 plus 1 into probability x1, x2 is equals to 1, that is 2 by 15. So this expected value will be 2 by 15. So this way we have find out the expected value of x1, x2. Now we need to find out the covariance of x1, x2. So covariance between x1 and x2 will be expected value of x1, x2, which is 2 by 15. So it will be 2 by 15 minus expected value of x1 into expected value of x2. So that is 6 by 15 into 6 by 15. So because both the expectations are equal. So it is 6 by 15 into 6 by 15. So this will be, if I just cancel out, then it is 2 by 5 and 2 by 5. So it is just 2 by 15 minus 4 by 25. So what is the, it is 75, and it is 10 minus 25 3 times, then it is 12. So that is minus 2 by 75. So this is basically the covariance between x1 and x2. Apart from that, what we need to calculate the correlation between x1 and x2. So which will be nothing, which will be covariance of x1 x2 divided by the standard deviation of x1 into the standard deviation of x2. Now in order to find out the variance of x1, we should have expected value of x1 square minus expected value of x1 whole square, and which will be equals to variance of x2, because x1 and x2 have same PMFs. Okay, so now expected value of x1 square we need to calculate, because we have not calculated that. So we'll calculate expected value of x1 square. So that will be 0 if x1 is 0, into probability x1 is equals to 0, plus 1 into probability x1 is equals to 1. And what is the probability x1 is equals to 1? So probability x1 is equals to x is 6 by 15. So this is 6 by 15. So variance of x1 will be 6 by 15 minus expected value of x1 whole square. So expected value of x1 is what? 6 by 15. So it will be 6 by 15 whole square. Okay. So it will be what? So it will be 3.
6 by 25.
Okay, 6 by 25. Okay, so it will be variance of x1. Then what we will find out? We'll find out the correlation coefficient. So rho will be equal to covariance of x1 x2, which we have find out already, minus 2 by 75. Okay, now this is equals to variance of x2 also. So if I find out the standard deviation for both of them, so that will be same. So that will constitute to be a variance of x1 only. So we will divide it by 6 by 25, which will be equals to minus 2 by 75 into 25 by 6. So it will get cancelled. So this will be 1 minus 1 by 9. So this is basically the correlation coefficient. So we are having negatively correlated. And we are relation is linear. Okay. So x and y are negatively correlated and linear, and the degree of correlation because since this quantity is near about the zero, so it is weak. It is a weak correlation. Okay. They are weakly correlated and weakly negatively correlated, we can say. So I hope these calculations and all the things are okay for this question. We'll move forward for the next question now. So the question says, raindrop falls at random on a square with vertices A. So first of all, we'll just plot this square. So I want to plot it for the next page because it is little. I'm plotting this square. Now what is it saying? The vertices are 1 0 0 1. So 1 0. So it will be 1 0. So it is a vertex 0 1 0 1 and minus 1 0 minus 1 0 and 0 minus 1. So basically we have this square. So our density is 1 in this region. Okay. Now if I want to integrate it over this region, then I should know the equation of these lines. So first of all, I will just name this line to be L1, this line to be L2, this line to be L3, and this line to be L4. And first of all, I will just find out the equation of these lines. Okay, because if I want to integrate and find out the expected value or anything, then I would need the equation of these lines in order to integrate it with respect to that thing, because we are the density is positive in this area only. Okay, so for this L1, first we will calculate now equation of line L1. So we'll calculate the equation of line. So what is the equation of line? That is y minus y1 is equals to y2 minus y1 divided by x2 minus x1 into x minus x1. So by this way, we just find out the equation of the line. So if I consider y1, y2, and sorry x1, y1, and x2, y2 to be these points, then the equation passing through these 2 points, the equation of the line can be found out by using these formula. So the equation of the line L1 will be, if you calculate by this formula, so it will be, so already, so you just calculate and just let me know what will be the equation of line L1. So just form it in the form of y, that y is equals to something. So it will be, so if I consider this to be x1 and this to be y1, so it will be y minus 0, that is equals to, so this will be y2, so it is y minus 1 minus 0 divided by x2 minus x1, so it will be 0 minus minus of 1, that is 1. So into x minus x1, that is minus 1, so it will be plus 1, plus 1. So it is y is equals to minus x minus 1. So this will be the equation of this line L1. Similarly, we'll find out the equation of line L2. Okay. So equation of L2 will be what? So this is the line L2. Here I am considering this 1 comma 0 to be x1 y1, and this is x2 y2. So it is x1 y1. So x minus 0, sorry, y minus 0 is equals to, so y minus y1, that is equals to y2 minus y, minus 1 minus 0, minus 1 minus 0 divided by x2 minus x1, so that is 0 minus 1, that is 0 minus 1 into x minus x1, x1 is 1, so x1, that is 1. So it is y is equals to, so this minus and minus will get cancelled, so it is x minus 1. So it will be y is equals to x minus 1. Yeah. Now similarly, we'll find out the equation of L3. So which will be, equation of L3 will be y is equals to 1 minus x, and equation of L4, by similar method you can find out. So the equation of L4 will be y is equals to 1 plus x. So finally we have found out the all the equation of these lines. Now why we have found out these things, I will be discussing now. So here what it is asking, that the random variable x is nothing but it is the x coordinate. If I consider x comma y, then random variable x will give the value x, which is basically the x coordinate, and y is the y coordinate. So we are assuming that the joint distribution of x comma y is uniform over this region, over this square, that is fxy is equals to 1 by 2 over this square. Okay. Now first of all, we need to check whether the x and y are independent or not. Now in order to check independency, we need to find the marginals fx and fy. Okay. Now if I want to find out the marginal of x, then what I should do, I should integrate the joint density over the region S with respect to y. Okay. Now if I consider the region S to be this, and I want to integrate it with respect to y. Okay, I want to integrate it with respect to y. Y is varying from this quantity. Now, in order to integrate a function with respect to y, first of all, I need to consider two regions. This region, this one, the left side one, this one, and the right one. Okay, so I consider this to be, for example, this region to be y1 and this region to be y2, the whole region. I'm varying the y and x is like this. Okay, so I'm considering this region to be y1. So if I consider the left hand side region, okay, not because we are varying y, so we'll consider the upper part of this x, because we are, if I consider y to be varying from 0 to 1. Okay, wait a minute. So if I consider y to be minus 1 to 1, we have y to be minus 1 to 1. But if I want to integrate this whole, the whole quantity varying y from minus 1 to 1, then I should consider only this region. Now for that, first of all, I should consider the region y1, which is this region, basically this whole region, and I consider y2 when y is between minus 1 and 0 and minus 1 to 0. So first of all, I'll consider, because we need to integrate it with respect to y. So I'll first of all vary y. So for y to be between minus 1 and 0. Okay. Now in minus 1 and 0, this means the region y2. What I will find out, the integration, and y is ranging from this one and x is ranging from where to where. Now x is ranging from this line to this line. Basically, I'm taking this split. So basically x is ranging from this line L1 to line L2. So here Fy is integration um, Fxy with respect to dx, where x is ranging from line L1 to L2. Okay. So x is from L1 to L2. And what is the equation of L1? So that is, if I find out in the form of x, then it will be x is equals to minus y minus 1. If I find out in the form of x, it will be minus y minus 1. So it will be, so integral minus y minus 1 to line L2. Now what is the equation of line L2 here? So it is y is equals to x minus 1, and if I find out this x is equals to y plus 1. So it will be y plus 1. And what is the joint density of this thing? So joint density is nothing but 1 by 2. So it will be 1 by 2 dx. So it is nothing but, if I, because the integration we have no x term, so it will be 1 by 2 y plus 1 minus this quantity. So that is twice of y plus 2. So it will be divided by 2. So it will be y plus 1. Now here y is ranging from minus 1 to 0. Now if I range y from 0 to 1, then what will be Fyy? So if I arrange, so it will be all obviously this integration of fxy dx. Now where the x is ranging, if y is ranging from 0 to 1, if y is from 0 to 1 here, then x is ranging from line L4 to L3. Basically this is happening. So x is ranging from L4 to L3 basically. So what is L4 here? So L4 is y is equals to x plus 1. So if I find out x is equals to y minus 1, so it will be ranging from y minus 1 to, if I find out x here, so x equals to 1 minus y. So it will be up to 1 minus y, or it will be 1 by 2 dx. So it will be 1 by 2, 1 minus y minus y plus 1. So it will be 1 minus y. So basically what is the marginal? So this is nothing but, it is 1 plus y. Y is between minus 1 to 0, and if y is between 0 to 1, it is 1 minus y, and it is 0 elsewhere. Okay, so these are basically the marginal for y. Now similarly, I can find out the marginal for x. Okay, now I have found out marginal for y first, and then I will find out, okay, now if I want to find out the marginal for x, Then also I need to integrate it over fxy dy. Okay, wait. Yeah, over dy. So basically I've done a mistake here actually. So I'm finding the marginal over y. So I have just integrated it with respect to x. I have taken the integration with respect to x only. So here I should take, because I am taking the integration with respect to x. So here I should take x, the values of x. Actually, the mistake I have done here. So, okay. So here, for that I need to change it. Okay. So I will just change it further. So actually, what I'm doing, I am here, if I'm considering this, the range of y means, okay. So yeah, I think it is correct. I think it is correct. So fyy will be same. Yeah. And if I find the value of fxx, then also by similar method, the value of this fxx will also be the same thing. So it will be of the form 1 plus x minus 1 x 0, and it will be 1 minus x for 0 x 1. By similar method you can find out for x only. Then in that case, if you are considering the it is varying over x, then in that case what you will do, you will consider this region, so this left hand region, this one, and this region. So just I will just make it more clear. So if I'm okay, if I want to find out f the marginal for x, before I find out the marginal for y, if I want to find out the marginal for x, then in that case I would find out the integration of the density with respect to y, and I will be varying over y. Okay, now if I consider this thing, now the x value is from minus 1 to 1. So basically x lies from minus 1 to 1. I want to find out the integration over this region. Okay, when x is varying from minus 1 to 1. Now in that case I will just uh, consider first of all the region x from minus 1 to 0, then x from 0 to 1. Okay, now in that case, for x between minus 1 and 0, what I will be doing, I will be integrating fxy dy now for this region. So this is basically this region. So this is, we have L1 and this we had L4. So I will be integrating it over y running from this thing to this ring. So that is from L1 to L4. And for x to the x value 0 to 1, what will be? So it will be integration fxy dy, and I have this region. So this will be, we are integrating from L2 to L3. Okay, so I will be integrating from L2 to L3. Now, because we are integrating it with respect to y, so we will find out the equation of these lies in the form of y, something y is equals to something. So what was L1? Let me so what was L1? So L1 was, so L1 was y is equals to minus x minus 1. So it will be y is equals to minus x minus 1 to L1 to L4. So L4 was y is equals to 1 plus x. So it will be up till 1 plus x. Okay, similarly we can find out for this, and then we'll get the density of fx to be equal to the density of y by y. So this will be same. Okay, now we need to calculate that whether x and y are independent or not. Now for that, fx the joint density should be equal to fxx into fyy. Okay. Now if I consider fxx to be this and fyy to be this, so this will be the product of 1 plus y into 1 plus x when x is running from -1 to 0 and y from -1 to 0. Now in that case it will never be 1 by 2. So it will be of the form. So basically I can say directly from there that these are not equal, because if I consider their product, then this will not be equal to 1 by 2, which is basically equal to which is the joint density we had, this one 1 by 2. So these x and y are not independent random variable. Now further what we need to calculate, we need to calculate the expectation of x and y. So for expectation of x and y, what we need to calculate, the marginal we have already calculated, so we will be finding out the expectation now. So now what we can say, now since the marginal density of x and y are same, marginals are same, so expected value of x will be equal to the expected value of y. Okay, and also the variance of x will be equal to variance of y. So what will be the expected value of x here? Now if I want to calculate the expected value of x, then since we have defined the marginal for x, the value of x from -1 to 0, then 0 to 1. So it will be integration -1 to 0 x fxx dx plus from 0 to 1 x fxx dx. Now from -1 to 0, what is the -1 to 0? What is the marginal from -1 to 0? So it is 1 plus x. This is 1 plus x dx plus integral 0 to 1. Here it is 1 minus x, I think. So it is 1 minus x. 1 minus x dx. If I find out its value, so it will be x square by 2 plus x to the power 3 by 3 minus 1 to 0 plus this is x square by 2 minus x to the power 3 by 3 from 0 to 1. So expected value of x will be, so this will be 0 for the upper limit. For the lower limit it will be 1 by 2 minus 1 by 3. So it will be 1 by 2 minus 1 by 3, and this is of negative plus. So it will be 1 by 2 minus 1 by 3 for the upper limit and 0 for this 1 by 2 minus 1 by 3, and which will be 0, as it will get cancelled, and it will be equal to the expected value of y. So it will be equal to the expected value of y. Yeah. Now we need to calculate the variance of x. So it will be expected value of x square minus expected value of x whole square. Now since expected value of x is 0, so it will be expected value of x square only. So we'll calculate the expected value of x square. So which will be equal to integral over x square f x x dx minus 1 to 0 plus integral 0 to 1 x square f x x dx, which can be calculated. So it will be what? So integral minus 1 to 0 x square into okay, in the question we have asked for expected value of x and y. Okay, we will calculate the variance of y also. So you just put the value of the densities here for the marginal densities here for both the scenarios. So what is the marginal? Let's write it. So it is 1 plus x and 1 minus x. So it will be 1 plus x dx plus integral 0 to 1 x square into 1 minus x dx. So it will be x cube by 3 plus x to the power 4 by 4 minus 1 to 0 plus x cube by 3 minus x to the power 4 by 4 0 to 1. So which can be calculated like it will be 0 for this and this is negative of minus 1 by 3 plus 1 by 4 plus 1 by 3 minus 1 by 4. So basically it will be added. So it will be 2 by 3 minus 2 by 4. So what will be the answer? It will be 12, 8 minus 6. That is 1 by 6. So expected value of x square is 1 by 6. So this will be 1 by 6 and expected value of x whole square is nothing but 0. So variance of x will be 1 by 6 only, which will be equals to variance of x and which is nothing but variance of y also. Okay, so I hope this is clear.
Yes, ma'am.
Okay. So I will be moving forward towards the next question. So it is if x and y follows bivariate normal distribution with mu, so it is x, mu x, mu y, sigma x square, sigma y square rho. Now we are considering the rotational transformation u v to be equals to cos alpha minus sin alpha, and this is basically the product. Basically, we are multiplying the. Okay, something maybe I have missed this question. Yeah, in place of this, I will edit it. In place of this, we have this matrix cos alpha, sin alpha, and minus sin alpha, and here we have cos alpha. Okay, so we have basically this product x minus mu x, y minus mu y. Okay, so this is basically what we are multiplying these two matrices and we are finding out the u and v. So u and v are this thing. Now suppose that sigma x square and sigma y square is greater than 0, mod rho is less than 1, which are all obvious. So then under what condition u and v are independent? Now u and v are independent when, so if the covariance of u comma v is 0, okay, then u and v are independent. Okay, now this is holding y. In general, this is not true because u comma v will be bivariate normal. Okay, because if u and v for u and v to be independent covariance u comma v should be 0. Okay, what we can say, wait a minute. No need of this thing. So basically they are saying that under what condition u and v are independent. Now for u and v to be independent, whatever dependency is there, they should be linearly independent also. So covariance of u comma v should be 0, means they are uncorrelated. Basically, first of all, we want to find the condition that when the covariance of u comma v will be 0, in order to say that under what condition u and v are independent. So covariance of u comma v should be 0 for u and v to be independent. Okay, so we'll consider the covariance of u comma v. Now covariance of u comma v is what? Expected value of uv minus expected value of u into expected value of v. Okay. Now for this, first of all, find out that what is u and what is v. So if I do the matrix multiplication, then this is this into this, that is cos alpha into x minus ux. So cos alpha into x minus mu x plus sin alpha into y minus mu y. So this into this thing is the first vector u, and what is v? So v will be minus sin alpha into x minus mu x plus cos alpha into y minus mu y. So these are basically our u and v. Now I want to find out first of all the expected value of u and expected value of v. So expected value of u is equals to what we have, this x minus mu x into cos alpha. So cos alpha is independent of x, so we can take it outside the expectation, and we'll take the expectation over x minus mu x. So it will be cos alpha expected value of x minus mu x. Okay, then plus sin alpha expected value of y minus mu y plus sin alpha expected value of y minus mu y. Okay, now expected value of x minus mu x is what? Expected value of x minus expected value of x minus mu x is expected value of x minus expected value of mu x. Now mu x is already a constant, so it will be a constant only. So that is equals to, now expected value of x is what? Mu x. That is like mu x minus mu x, which will be 0. And similarly, the expected value of y minus mu y is also 0. So which will imply that expected value of u is 0. Now similarly, if I do for the v1, so expected value of v, so if I see that v is minus sin alpha x minus mu x, so if I find the expectation, so it will be minus sin alpha expected value of x minus mu x plus cos alpha expected value of y minus mu y. Again both the terms will be 0, so expected value of v will again be 0. So now covariance of between u and v will be nothing but expected value of u into v. So for that we should find first of all what is u into v. So it will be the multiplication. So that is cos alpha into sin alpha minus and x minus mu x whole square. So minus sin alpha cos alpha into x minus mu x whole square plus, so cos alpha into cos alpha, that is cos square alpha into x minus mu x y minus mu y. So it is cos square alpha into x minus mu x into y minus mu y. Okay. Plus sin square alpha is in minus and x minus mu x into y minus mu y. So we'll take it as minus here. So minus sin square alpha x minus mu x into y minus mu y plus, what is the next term? So it is multiplied. Now sin alpha cos alpha into y minus mu y. So sin alpha cos alpha into y minus mu y whole square. So we will be using some of the trigonometric identities, that is sine 2 alpha is equals to 2 sine alpha cos alpha, and cos 2 alpha is equals to cos square alpha minus sine square alpha. Yeah, so we will be using this. So here if I take this sine alpha cos alpha common, then we need to find the expected value of uv here. Okay, so expected value of uv if I find out, then first term will be minus sine alpha cos alpha expected value of x minus mu x whole square. So it will be, so expected value of uv will be minus sine alpha cos alpha into expected value of x minus mu x whole square. Okay, again next term will be plus cos square alpha expected value of x minus mu x into y minus mu y. So basically this expectation is of this product plus minus sine square alpha expected value of this thing. So I can write it in the combined form. So what I will write it. I take this cos square alpha minus sine square alpha into expected value of x minus mu x into y minus mu. I have taken this common. Okay. Now plus, what is the next term? Sine alpha cos alpha into y minus mu y whole square. So it is sine alpha cos alpha, or what I can do, I can just take it common here, minus, and this is plus expected value of y minus mu y whole square, because sine alpha cos alpha is common for both the terms. I have taken this common. Now in place of sine alpha cos alpha, I can write sine 2 alpha by 2. Okay, so it will be expected value of uv will be minus ka sine minus of sine 2 alpha by 2. Now here you can see that this is nothing but the sigma y square, that is expected value of y minus mu y square, that is sigma y square, and this is nothing but sigma x square. Okay. Now this term cos square alpha minus sine square alpha, I am taking it as cos 2 alpha. So it is plus cos 2 alpha into, so now what is this? Expected value of x minus mu x into y minus mu y. Now what is this? This is basically covariance between x and y. Covariance between x and y. Now x and y in the question given that x and y are bivariate normal distribution. Now for bivariate normal distribution, we know that covariance is sigma x sigma y into rho. So we will be put those values here. So it will be minus sine 2 alpha by 2 into sigma y square minus sigma x square plus cos 2 alpha into this covariance is this is into rho sigma x sigma y. Now in order to u to be u and v to be independent, this expected value should be 0. Okay. Now in order to this to be 0, this quantity should be equal to this quantity. So basically which is true if sine 2 alpha divided by 2 sigma y square minus sigma x square, this quantity, is equals to cos 2 alpha into rho sigma x sigma y. So which implies if I take this cos 2 alpha here, so this will be tan 2 alpha, which will be equals to rho sigma x sigma y, and 2 will be there, and sigma x y square minus sigma x square. Now in question it is given that suppose sigma x square is equals to sigma y square. Now if sigma x square and sigma y square both are equal, then this quantity, now if sigma y square is equals to sigma x square, so LHS will go towards infinity. So which implies LHS goes towards infinity. Now for the left hand side, for that to hold, this 2 alpha, for that 2 alpha should be equals to pi by 2, because tan pi by 2 is infinity. Okay. So because here they are saying that alpha is between 0 and 2 pi, and between 0 and 2 pi, pi is a quantity where the 10 becomes infinite. So this implies that 2 alpha should be equals to pi by 2, which implies that alpha should be equals to pi by 4. So this is the condition, so which is necessary for x and y to be independent. If alpha is not pi by 4, then u and v cannot be independent. Okay. So for u and y to be independent, the covariance should be 0. So by those conditions, we have just found out this condition that alpha should be pi by 4 in order to u and v to be that independent. Okay, is there any doubt in this question? Okay, so if there is no doubt, then I will just take one more question for today's session. So that is,
Just a minute. Can we like why when you took the sine 2 pi by 2 alpha by 2 to the other side, with we had sigma square y minus sigma square
yeah.
x,
Mhm.
right? Can we put that value to 0? Then the equation will come down to cos 2 pi into rho into sigma x sigma y.
So what you are saying, what you will do?
Like sigma square y minus sigma square x will go to 0.
Okay.
So the equation will be left will be like on the right hand side only, like the first row. So it will be cos 2 pi into rho into sigma y sigma x is equal to 0.
Yeah.
So cos 2 pi will go to 0 then,
Yeah.
because
Cos to by, see, the mod rho is less than 1. Yeah. So rho cannot be 0. So yeah,
yeah,
then so in that case, what will be holding that cos 2 alpha is
yeah,
0.
cos 2 alpha is 0. Yes. So
Yeah.
we can check the values of cos at which it is 0. So it will be, I think, uh, pi by 2. I don't remember the exact values of
Yeah.
cos.
What cos is 0? So cos 0 is 0 basically, and
I,
uh, and
yeah.
cos 0 is 0. No, not cos 0 is not 0. So because we have
Sine 0 is 0, I think.
sine 0 is 0. So cos 0 is not 0. So the graphs are like this for cos theta. So cos 0 is here, and here I think
It's pi by
we have
2.
cos pi by 2,
2.
or
Pi by 2, I think.
yeah.
So
So then
this,
also 2 alpha will be pi by 2 only, no? And alpha
yeah,
will
well,
be,
it will resolve a lot of calculation.
yeah, yeah, yeah. You can because here actually the thing is like that 10 becomes infinity. Yeah, that's also fine. That is no issue in that also. That cos alpha is 0, because here the thing is. Yeah, because rho is always positive. Sigma x and sigma y are also non-zero. Then you can do it by that thing also. Yeah, that's also fine.
Yeah, because it will not form 0 by 0 form. Because we have rho is not going to 0 and sigma y and sigma x are not equal to 0.
Yeah. So it is not a 0 by 0 form. So it is
Yes.
basically going to infinity only. So we are just
Uh,
assuring this thing that this is not a 0 by 0 form. So I'm just thinking of that only, that now whether some kind of situation arises for this. So yeah. So if you have alpha to be 0.
not alpha to be zero. Sigma square y is given that is equal to sigma
Yeah,
square
yeah,
x.
yeah, yeah. This is given that sigma x square is equals to sigma y square. Yeah, you can do it like that also. That is also fine because it is going to zero means cos 2 alpha is going to zero because rho and sigma x sigma y are not equals to zero. So this will imply that this 2 alpha is pi by 2. So alpha is pi by 4. Yeah, that's fine. I think it is correct. So you can do by either way. Okay, so we will be moving forward towards the next question. So here we have this x comma y is bivariate normal distribution with mu 1 to be 1 mu, or we can say this is mu x. So I can write that mu x is 1, mu y is 1, sigma x square is 4, sigma y square is 9, and rho is 1 by 2. So what we need to find the distribution of y given x is equals to 3. Okay, so we know that what is the distribution of y given. So y given x follows the normal distribution with what mean and some variance. I will be writing that. So x given y, so y given x will follow the distribution with mu y minus rho sigma y by sigma x into x minus mu x comma sigma y square into 1 minus rho square. So the mean will be, so x, the value of x is 3 here. So mean will be, so mu y is what? 1 minus rho is what? 1 by 2. Sigma y is 3. Sigma x is 2. And x is here we have 3 minus mu x we have 1. Okay, so this will be the mean. And what will be the variance? Sigma y square will be 9 into 1 minus 1 by 2. Okay, so which is normal. So this is 3 minus 2, that is 2 will get cancelled. 1 minus 3 by 2, that is, okay, so rho will be 1 by 2. Mu y is 1. Okay, wait, this is 1 plus actually. This is plus here. So it is 5 by 2, I think. Yeah, 5 by 2. And this is 9 by 2.
Shows here. I think it will be maybe 1/4.
Yeah, it is 1 by 4. It will be 3 by 4. It will be, okay, let me write 27 by 4. And again, what we need to find at x given y is equals to 3. So it follows normal with the mu x. So what is mu x? Mu x is 1. So that is 1 plus rho, so which is 1 by 2. Sigma x by sigma y, I think. Yeah. So sigma x is what? 2 and sigma y is what? 3 into y minus mu y. So y is 3 here minus mu y is 1 here, comma sigma x square, and sigma x square is 4 here and 1 minus rho square which is 1 by 4. So that is normal. So this is again get cancelled. This is 2 comma this is 3. So y given x is equal to 3 follows normal with mean 5 by 2 and variance 27 by 4. And x given y is equal to 3 follows normal with mean 2 and variance 3. So so these are the basically the directly we are using the formula which we have already derived in week 6 lectures. So this will be the conditional distribution, which will be the univariate normal distribution. So I hope you understood the questions which I have explained today.
Yes, ma'am.
Okay, so I will be ending the session after a discussion. If you want to like put forward any doubt or anything, then you can just uh, discuss that. So at the end of this, all the lectures, I will be holding an extra session maybe. Then in that, I will be discussing more questions on this topic. Uh, because there are many integrals and all those things in the way we are drawing the regions and all those things. I will be discussing more on those more about this topic in that extra lecture. But for now, it will be these questions only. If anyone has any doubt, then please just tell me. Okay, if there are no doubts, then I will be ending this meeting.
Thank you, ma'am.
Thank you all of you for
Thank
listening.
you, ma'am.
Thank you.